Okay, here we go with notes for 1A. This is part 2. So you can see here it asks me to draw some common tangents. So if you remember from the first part, a tangent is a line or a ray or a segment that intersects a circle at one point. If it intersects two or is tangent to two circles, then it's called a common tangent. So we've got 5 different scenarios here of what it could look like. If I have a picture like this, I could have a tangent line here, intersects the circle here and here. I could also have one here. Whoops, there, close enough. Okay, and those two are called external because they're kind of on the outside. I can also have one that kind of crisscrosses in the middle here. And that would be internal because they're inside. Okay, so this one would actually have 4 common tangents. The snowman one, we're going to have some on the outside here, and each of these lines intersects the circle that it's by at one single point. You can also have this one where they are meeting right there, so this one would have 3 common tangents. Okay, this one you can see is going to have just 2. This one is kind of a circle within a circle. They meet right here, so I can have a tangent line out here. So there's 1 common tangent for that. And you can see here there's no way that I could draw a line that would intersect each circle at just one single point. So we would have 0 common tangents here. In fact, this situation, which is like a bullseye, is called a concentric circles. Okay, concentric circles are those that have the same center, but they have a different radius. Okay, kind of like a bullseye. If I have 2 segments from the same exterior point, so like on this picture here, this point B out here, I've got common tangent on this side and a tangent, I'm sorry, not common, but a tangent on this side and a tangent on this side. This one says this rule is that they are congruent. So AB is going to be equal to CB. Okay, and the rule is if from a point outside the circle, called an exterior point, is tangent to the circle on both sides, both of these segments here are going to be equal to each other. So let's see how that is used here in this problem. So they tell you a lot of information here. So AB and CB are tangent to circle D. So AB and CB are tangent. So we learned just from up there that those 2 segments are going to be equal. To set that equation up then, I'm going to use my algebra to set up the equation that they are equal to each other. When I subtract x and add 5, I get x equals 20. Now they've just said in the directions here find x, but if they actually wanted me to know how long AB is, I'd have to plug it back in there. 20 plus 15 would be 35. I could double check it over here. 2 times 20 is 40, minus 5 is also 35. So we did get the correct value of x. This would answer the question. Okay, it's the same situation here. We've got an exterior point W is tangent to circle R at point P and point Q. So these 2 segments are going to be equal to each other. So I'm just going to set it up as with an equation. Subtract. And then again, x equals 8, so you could go back and plug it in here to see if you get the same values. And last thing on our list here is we're just going to summarize some of those words that we learned on the first page. So real quick, what is the best description for AC? So using these words here, AC goes from the center point to a point on the circle, so that would be a radius. Segment AB. AB, okay, is also goes from a point on to a point on. That overall is called a chord, so that would be one example I could write there. But when it goes through the center like this, a better word probably is the diameter. Okay, the diameter is the longest chord on the circle. Line DE Line DE is out here. It intersects the circle at just one point, so that would be called a tangent. And line AE, which is this one here, here's E, goes through there, so it's a line that intersects it at two places. That's called a secant. Okay, if you need any other explanation, please let me know.